CubeSat. We're hoping to have these two standards. Standard 1 is sort of out there, at least in the form of an interface control document, and we're hoping to have Standard 2 published here within the next month or so. So just to give you an idea of a little more detail on the standards. Standard 1 is very similar to the CubeSat standard. There's a power on switch. The spacecraft must be powered off during launch. There are set springs, and the deployables have to be constrained during the stow condition for launch. Normally there's an inhibit period, an RF inhibit period, it varies amongst the launch providers, but often almost always there's an RF inhibit period, 45 minutes or something like that. So you do need a timing circuit that will allow you to inhibit the transmissions during that inhibit period. But this, I think, is a kind of a useful slide here because it shows you the relationship between the Pocketqube standard itself and the deployer. And I think from my perspective, I think there are two major enhancements for the Peapod deployer. One is the slide rails, the sled effect, because it's just captured by these guide rails. And what that does is really it helps during the ascent stage because in the Peapod, the CubeSats can literally shake or even provide the sled where you build the.
It's actually kind of based on the standard PCB.
Oh, that's right, yeah. So the
So
width
you
and
could
the
actually
size.
put components on it if you wanted, and all we care about is just on that edge where it slides in the rail. And then the other thing, notice you drag your antenna along the inside. I think that helps an awful lot. That you don't have to tie them down like in the CubeSat.
Right, exactly. So yeah, in addition to sled, that's I think the other innovation is that you really have all the space around it that could be utilized to some extent. The typical procedure for stowing the antennas, as Bob mentioned with the CubeSats, is a monofilament, basically a fishing line, and a line cutter, a little resistor that's a line cutter. And there have been occasions when those systems have failed, and it's been tough to deploy the antenna systems. But if they're just constrained by Mr. Pod, it really is, it reduces the risk element. It's a risk element. So I think that's a neat other advantage. And we'll make these all available, but just to give you an idea of the space that's available in the deployer around the Pocketqube itself, which several people have taken advantage of. So here was the first Mr. Pod. It's a 3D printed model down on the left, and the final version on the right. This was Mr. Pod 1 that was flown in 2009. Unfortunately, the Russians put satellites in 2009, but we did in 2013. Launch on 4 of them. So you can see the designs evolved for the deployer over time. And I think you guys have seen this guy passed around launch rails. A couple of different options for the cutoff switch mounting, and you can see that there's people use rocker switches, separation switches like that. So you have different options for the cut switches. And again, the dimensions for the different options, you have a lot of flexibility in where you use the volume. So option 2 gives you you have a little side, a little room on each side of the sled. Or option 1, option 2, pretty much one side or the other. And option 3, take up the entire volume. Side views for each of those options. And then Bob had mentioned, do you have the model actually of the 8?
Well, there's one of them.
Okay, so this is the Pocketqube 2.0, but I think it's easier to see when you look at this slide configuration, how they'll come apart in the 2.0 standard. And so it's essentially again just taking a Pocketqube and dividing it into the 8 sections here. Anyway, we'll make the slides available so you can see the actual dimensions and make sure that you have. But I thought it was useful to take a minute and talk about the deployer and the dimensions that are available. let you think about the design aspects.
Okay.
Question.
Yes.
You talked about an RF inhibitor.
Yes.
Are there any rules about battery charge? Is that actually drained when you launch?
Yeah, so it depends on the launch services provider. Typically, you have no access once you're integrated to top off the batteries. So we've had instances where
But you can fly with a charge.
you can fly with a charge, exactly, but you have to worry about self-discharge rates. And we've sat on the shelf for as much as 6 months at a time. So typically, that's an excellent question, because typically what you do is you have 2 sets of batteries. You might have your flight model and your engineering model, and we always charge them at the same time and measure the self-discharge rate, so you know exactly what your state of charge is once you get launched, because it might be the launch is always split. We're the kind of the barnacles of the space industry. We tag along with secondary payloads on rockets that launch big paying customers. And so you kind of have to get the ride that what's available. And so sometimes there will be launch slips, and if it's integrated, they won't deintegrate the secondary payloads. So you might sit on the shelf. You might think you're going to sit on the shelf for 3 weeks, and it could be as much as 6 months. So self-discharge is an important thing to measure that we discovered.
Great. One of the things, I wish I had all of you to give some input in, because we're just designing this right now. You see the red lines. The idea is use the usual nylon lines to tie things together. And then what I'm planning on is each of the cubes have a line cutter on it. And so that, there's redundancy in getting the line. It would be such that if you cut the line in one place, I think the probability is pretty good that the whole thing would come apart. But the way, the inhibit switches are, they're a hindrance in a lot of ways. So I thought about, and it's not, I don't know whether anybody's done it, but why don't we fly with a dead battery? Because we have to wait for a while for this thing to start up. Fly with a dead battery, and then when it gets up to voltage, then do the line cutters. And it saves you an inhibit switch. And I don't know whether you damage those batteries. It depends on the type you got. If you discharge them completely and let them set that way for a while, I'm not sure that would hurt them. But anyway, that's a thought. If somebody else has got another suggestion, that the thing that you always want to do is minimize the kind of things that you've got to do. You want to minimize the number of parts you have to prevent errors on it. Now, one of the things that I've started here, and I'd like your input on it, is